So this number 4, this was from our Monday work. So if you weren't understanding this problem, you need to go back to your Monday work and check to see, rewatch this video to help you understand this better. When we are classifying real numbers, we talked about all those different sets and subsets. So I have a whole bunch of different numbers. All these different types of numbers are called real numbers. There was one group that was kind of off all to themselves, and those were my irrational. Those are my irrational numbers. The ugly square roots, pi, numbers that have decimals that do not repeat and do not terminate, they do not end. Those are irrational. And then over here, for my real numbers, in the middle, to itself, we had the natural numbers. Remember, those are your counting numbers, like 1, 2, 3, 4, 5. If you can count to it, it's natural. Outside of natural, we had whole. Remember, whole numbers, because the natural numbers are inside of them, that means all of my natural numbers are also whole. And then we just add the number 0. Outside of whole, we had integers. Remember, natural numbers and whole numbers are inside of integers. So all my counting numbers, 0, are integers, plus we add in the negatives of all those numbers. Negatives of those numbers are also integers. Think about a number line when you think about integers. And then containing all of those, we had our rational numbers. Our rational numbers are our decimals that either repeat or stop, they terminate. And then also all the integers, all the whole numbers, all the natural numbers, all those things are rational as well. We talked about in the video notes how it's like toothpaste. Toothpaste, you can squirt toothpaste out, but you can't put toothpaste back in. So my natural numbers are all of those things because it's like toothpaste, it squirts out. But my rational numbers can't go back in. My rationals can't be whole if they're only rational, okay? All of those things are real numbers. So that chart that we did in our notes is going to help you here. We talked about how you need to simplify before you classify. So here we have the negative square root of 49. Remember, when the square root's on the outside, I think, what is the square root of 49 first? That's 7. Then I throw the negative on the outside. So negative 7, if I just go to put it on my chart, it would be an integer because it's on my number line. So remember toothpaste, because it is an integer, if I push my toothpaste out, it's also a rational number. It's also a rational number. It's not irrational. It doesn't have a decimal that, it doesn't have a decimal at all, so it's not irrational. It's not a whole number because if I start counting, I'm not going to count to negative 7. And the same thing with the natural number. I'm not going to count to negative 7. The next one, 4.25, repeating. Remember, like we said, with repeating numbers, we see repeating numbers in rational. Repeat, rational. So my 4.25 repeating would go in rational. It's not irrational because irrational decimals do not repeat. Because it's only a rational number, it can't go back in. So it can't be an integer, it can't be a whole number, it can't be natural because it's got the decimals. We only see decimals in rational or irrational. Remember, irrational means not. IR means not. So I can't be rational and not rational at the same time. That doesn't make sense. I can only be one or the other.